Now in the previous example, we gave you a sum and then we asked you to expand. Now in example 5, we want you to do the opposite. We will give you a series and we want you to write it in sigma notation. There's no need to evaluate. Now look at A. Now A says you have 3 plus 6 plus 9 plus 12 all the way to 99. Now if you can see the pattern straight away, good. If you can't, then you can always simplify to write it like this. 3 is 3 times 1, 6 is 3 times 2, then you have 3 times 3, 3 times 4 until 3 times 33. And then you can see that the general term actually looks something like this, 3r. So you use the general term to write it down in a sigma notation with the lower limit 1, upper limit 33. So how to get 1 and 33? If you sub in 1, remember you must get 3. If you sub in 33, you must get 99. Okay, so that's how you check. Now there's another way you can represent your sigma notation. You can choose not to have the lower limit to be at 1. Okay, you can actually write it down like this. 3 times r minus 1, lower limit will now be 2, upper limit will now be 34. The two expansions will give you the same set of numbers, so they are both similar. Now let's take a look at B. Now B says you have 3 square plus 5 square plus 7 square plus 9 square all the way up to 51 square. Now I hope you can see that actually all these numbers are odd numbers. And odd numbers, you can always write an odd number like this, 2r plus 1, or like this, 2r minus 1. So if you want to write down the sigma notation, again you look at the general term. You look at the general term and then you write your sigma notation with the general term inside. So you can either write 2r plus 1 or 2r minus 1. The only difference will be the r values. And if you look at the first one, the r value should start from 1 to the upper limit of 25. How to get 1 and 25? Remember, when you sub 1 in, you must get 3. When you sub 25 in, you must get 51. Same thing for this one over here. If you want to use 2r minus 1, now what should your r value be? It should be 2. Because when you sub 2 in, you get 3. When you sub 26 in, you get 51. And then there's the square and the square. Easy? Now, before we continue with C, there is a typo that I need to alert all of you to. Look at this number. This number should be minus 12. So please make that change in your notes. Now for C, you have 1 minus 2 plus 3 minus 4 plus ... minus 12. Now if you can see the pattern, good for you. If you can't see, then again, always do what I always do. You try to simplify them. Okay, you write them in terms that resemble some form of pattern. Okay, you can write this as 1 plus bracket minus 2 plus 3, then plus minus 4 and so on. Alright? Then you will have noticed that every odd term is a plus. Every even term, there's a minus in front of it. So how do we write that down in general term? Okay, we have seen this before in the previous chapter. What does this mean? What does this give you? If r is odd, this is even. So that means every odd term will give you a plus 1. Every even term will give you a minus 1. So this is how you come up with the plus minus alternating signs for the sequence or the series here. Now the remaining piece is just 1, 2, 3, and quite easily you can write it as r. So this sum can quite easily be r equals to 1, lower limit 2, upper limit 12, minus 1 to the r plus 1, r. Now, there are other representations. You don't have to stick with this one. You could have used this. Okay? They are all similar. Another one that you can also use is from summation r minus 1 to the r minus 1. And then r runs from 2 to 13. Now, it's not important to know all the different representations, but it's important to know how you can change from one representation to the other representation. We will talk about this in the next few examples. But before that, can you try D on your own? I can help you start. Take out the minus sign. Then you have 2 to the 1. Then you have plus 2 square. I hope you can see the direction that I'm going. Every odd term has a minus sign in front, and every other number is a power of 2. Can you see that? Until the last number, minus 1 to the power of 7. And then this is the same as summation. Okay? You always want to have odd terms to have negative in front. So you add a minus 1 to the r there. And every number is a power of 2. So it's 2 to the power of r. Okay? And r starts from 1 to 7. You can try this out. Take 1 in, you can sub it in, you get minus 2. You take 2 in, you sub it in again, and you have plus 2 squared. And then you can check your answer. In the end, you have this. Okay?